Hello everyone, hope you all are doing good. So today we are going to solve together AWS Certified Developer Associate Official Practice Exam, which is available on AWS Skill Builder. The idea behind recording this particular video is to help you out in your preparation journey for the AWS Certified Developer Associate certification. Okay, so click on Start Here button, and when you will click on Start Here button, you will be landing to this particular page. Okay, this page is giving you an option to start your official practice test. Now I'm starting this official practice test in the review mode. So I'm choosing review answer as on and I'm clicking on start button here. These are the instructions. You can read about the instructions from here. Like AWS certification official practice exam provides a practice exam experience that matches the question style of the certification exams. Okay. And there are other instructions too with respect to the Certified Developer Associate official practice exam. Includes 65 questions and a practice exam lab. It has a time limit of 130 minutes. Okay. If you want to read more instructions, you can read instructions with respect to length of time, whether you see correct answer and feedback, and other pointers too. Okay. Now, this option of review answers will not be applicable in your real-time examination. It's a kind of simulation exam which we are basically attempting here to get an idea on the question style. Okay. So let's quickly start this. Say start. And as soon as I click on start button, I will be navigated to my first question. It is saying that a development team runs an extensive set of automated tests by using an AWS code build action in an AWS code pipeline test stage. The test takes 30 minutes to run for each build. The team wants to reduce the time necessary to run the test by conducting multiple tests in parallel. To accomplish this goal, the team breaks the test into multiple independent segments. Which solution will meet these requirements? So I can see I have four options in front of me. Configure the multiple parallel code pipeline stages to run each test segment in a code build action. Configure multiple parallel code build actions to run each segment within the code pipeline test stage. Configure multiple sequential code build action to run each segment within the code pipeline test stage. And finally, we have configure the code build environment to use build underscore general 1 underscore 2x large compute type. Run each test in sequence with the code pipeline test stage. Now make a strategy to remove the incorrect answers first. It is talking about to execute the multiple tests in parallel. Okay, so remove the options which is including sequential. So if you will see option C and D, in C and D it is talking about sequential actions, multiple sequential action in option C, and in D it's talking about increasing the compute capacity, compute time, changing the compute time. Okay, so I don't think these two options are relevant. What is left in front of you? Configure multiple parallel code pipeline stages to run each test segment in a code build action, and configure multiple parallel code build actions to run each segment within the code pipeline test stage. So code pipeline is basically an overall pipeline which you are creating in order to run a CI/CD pipeline, continuous integration, continuous delivery, continuous deployment. Okay, means I will have to configure multiple parallel code build action as a part of code pipeline. So code pipeline is an entire pipeline. Inside this pipeline, you can use code commit, you can use code build, you can use code deploy, or you can use other AWS DevOps tool sets. So let me choose option B and let's see the correct answer. So B is the correct answer. You can also read about it. Code pipeline stages run sequentially. Only action within the same code pipeline can run in parallel. So you have to focus on the keyword called actions. And now if you will see option B, code build can run test actions. A single code pipeline stage can run many code build actions in parallel. And that was our requirement. So B is the correct answer. Okay. Let's move to the next one. A company integrated a third-party online auction application into the company's website to sell rare products. The third party created the auction application by using serverless technologies. The application stores data in Amazon DynamoDB. The DynamoDB tables are in the company's AWS account and under the control of the company's development team. The development team wants to create a new application to add custom functionality that will apply to newly placed bids in the auction application. However, the team must meet the following requirement. The team cannot change any of the third-party auction application code. The new application must be serverless. The new application must invoke the new functionality as soon as a user places a bid. Which solution will meet these requirements? Let's read the options. Code a new application that posts the DynamoDB table every minute for bids. Apply the custom functionality when the new application finds new bids. Deploy the new application on a single EC2 instance. It's talking about serverless. Serverless is a keyword. EC2 is not a serverless. Remove the EC2 option. Okay. Option B, code a new application that posts the DynamoDB table every minute for bids. Apply the new functionality when the new application finds new bid. Package the new code as a Docker image. Deploy the new application in the ECS on AWS Fargate. AWS Fargate is a serverless service. But before that, let's read other options too. In option C, it is saying configure the DynamoDB table to use DynamoDB stream. Create an AWS Lambda function with the DynamoDB stream as an event source. Code the Lambda function to apply the new functionality when the stream messages correspond to the newly placed bid. So it is somewhat looking towards the automation as well as serverless, because Lambda is a serverless service, DynamoDB is a serverless service. If we'll compare that from the option number B, in the option number B, there was a manual effort where it was saying that poll the table every minute for bids. Okay. In option D, it is saying create a delivery stream in the Amazon Kinesis data firehose. Configure the delivery stream to read the changes from DynamoDB table. Now, if you're aware about Kinesis data firehose, you would be knowing that Kinesis data firehose does not allow to put the records directly from the DynamoDB. So this option get false at this particular stage. So no need to read these options further. If you want, you can read it. Okay. Let's try to choose the best possible answer. Let's try with C. And you can see C is the correct answer. You can read about the description. You can see DynamoDB stream captures a time-ordered sequence of item-level modifications in any DynamoDB table. DynamoDB stream stores this information in a log for up to 24 hours. Application can access this log and view the data items as the items appeared before and after they were modified in near real time. A Lambda function is a serverless solution to send a message from the DynamoDB stream. Okay, so this is a most possible suitable option as compared to the other options mentioned here, and also it satisfies all the requirements which have been listed down here. Okay. A company creates an online platform that uses an Amazon S3 bucket to give users the ability to upload and share videos. The company has integrated the platform with a mobile app that gives users the ability to record and immediately upload videos. A user is unable to upload videos and submits a support ticket for the issue. The company discovers the following error message related to the user's multiple upload attempt. And the message is entity too large. Your proposed upload exceeds the maximum allowed size. Which solution will prevent this issue in any future upload attempt? Let's see the options. Increase the maximum size for upload for the S3 bucket. Implement multi-part upload logic on the mobile app. Increase the maximum capacity for the S3 bucket and implement S3 transfer acceleration on the S3 bucket. Now, something is related to the allowed size. The first option doesn't seem valid. It is saying increase the maximum size for upload for the S3 bucket. We know that when we talk about S3, we have a restriction with respect to the size of a single object that we can upload to the S3 bucket, and that is a 5 terabyte. Okay. So option A does not look correct to me. Option C, increase the maximum capacity for the S3 bucket. S3 is a serverless service. You don't have any visibility to the underlying infrastructure. Okay. So you can't basically talk about servers or anything related to the capacity. So C is also not looking correct to me. D says implement S3 transfer acceleration on the S3 bucket. Now, transfer acceleration is a feature which is used to improve the transfer speed to the S3 bucket. But here it is complaining about proposed upload exceeds the maximum allowed size. which is an option left in front of us. Option B. Let's try that. B is correct. When we say multi-part upload means we are basically splitting a large file into the multiple small files so that we can upload those small files and later those files can be consolidated together in a single file. Okay. So the file size exceeds the maximum upload size limit for a single put operation. You can use multi-part upload in the S3 to upload larger files. Okay. A developer is building an application using an Amazon API gateway, REST API backed by an AWS Lambda function that interacts with the Dynamo DB table. During testing, the developer observes high latency when making requests to the API. How can the developer evaluate the end-to-end latency and identify performance bottlenecks? So if you are aware about AWS services, in AWS, whenever it comes to performance bottleneck, we have a service called AWS X-ray. So this is a service used by developers in order to debug the performance bottleneck when you are tracing the request. Okay. So you can read all other options. Let's say enable the CloudTrail logging and use the logs to map each latency and bottleneck. So CloudTrail is basically used in order to audit the API calls made to the AWS services. We'll read option B at the end. Option C, enable Amazon CloudWatch logs for the Lambda function. Enable execution logs for API gateway to view and analyze user request logs. Enable VPC flow logs to capture and analyze network traffic within the VPC. Nowhere in the question is talking about a VPC, so this option does not look correct to me. And again, when it's talking about Amazon CloudWatch, Lambda has a basic execution role to put the logs in CloudWatch, but here it is talking about performance bottleneck. And as I told you, you can configure X-ray tracing on gateway and Lambda function, and then you can use X-ray to trace and analyze user request. Because AWS X-ray gives you a service map. Using that service map, you can basically have a visualization. You can track the performance bottleneck. Let's choose option B and say confirm. It is correct. You can read about it. X-ray gives you the ability to trace latency issues with your API gateway APIs. X-ray provides an end-to-end view of requests as they travel through your application. X-ray can be used to trace and analyze user requests. These collected traces give you the ability to evaluate the end-to-end latency and identify performance bottlenecks. Okay. A developer tests an application that a company developed by using AWS Lambda. The Lambda functions are behind an Amazon API gateway API. The timeout for the API method is set to the same timeout as a Lambda function. When a request is sent to the API, the response are timing out. Which action would help the developer troubleshoot the issue? So now the problem is with respect to the timeout here. And we have set the same timeout at the API level as well as at the Lambda level. Okay. So now we need to collect the data points. Now we need to understand the metrics or analyze the metrics which is associated with the API gateway. But we need to figure out which metric we should see in order to troubleshoot this issue. So let's read the option. Check the integration latency metric of the API in the CloudWatch. Check the duration metric for the Lambda functions in the Amazon CloudWatch. Check the count metric of the API in the Amazon CloudWatch. Check the error metric for the Lambda function in the Amazon CloudWatch. Now read the question, few points in the question. It is saying that when a request is sent to the API, the responses are timing out. Means here we are talking about integration between API gateway and Lambda because API gateway is acting as a front door. When the request will navigate it to the API gateway based on the type of request, it will basically navigate the request to the integration service. So let's choose the option, check the integration latency metric of the API in the Amazon CloudWatch. And you can see the API gateway integration latency metric denotes the time between when the API gateway relays a request to the backend and when it receives a response from the backend. The integration latency metric would help to diagnose the issue. Okay, so A is the correct answer here. You can also see other options before I'm proceeding towards the next one. Option B, check the duration metric for the Lambda functions in the CloudWatch. Check the count metric of the API in the CloudWatch. And check the errors metric for the Lambda functions in Amazon CloudWatch. A development team uses AWS code build to build an application. The developers observe that downloads of a large dependency files consume most of the time on each build. The downloaded dependency files are stored in a /.m2 folder. The builds are run frequently. Which set of actions would most improve the build performance? So here we are talking about improving the build performance. Let's read. Modify code build project to implement Amazon S3 caching. Modify the build specs cache setting to include a path to the /.m2 folder. Second option, option B, modify the code build project to implement a local caching. Modify the build specs cache settings to include a path to the /.m2 folder. Option C, create a shared code build project. Call the put resource policy API to include a path to the /.m2 folder as a shared resource. And option D, create an AWS code artifact repository as an upstream repository. Modify the build settings with the repository URI and the authorization token. Okay. Here the issue is the developers has an observation that downloads of a large dependency file consume most of the time on each build. Okay. Let's read the option B. Modify the code build project to implement a local caching and modify the build specs cache settings to include a path to the /.m2 folder. Okay. And the downloaded files are stored in a /.m2 folder. Okay. Let's see this. So option B is correct. Why? Let's see the answer. The first one was asking you to implement S3 caching. A cache can store reusable pieces of your build environment and use these pieces across multiple builds. S3 caching stores the cache in the S3 bucket that is available across multiple build hosts. This is not an ideal option for the large build artifact because the artifact can take a long time to transfer over your network, which can affect build performance. My requirement was to improve the build performance. If we are implementing the caching in the S3, in order to transfer the files, in order to transfer the artifacts, it will take a long time over the network. So A should not be correct. B saying again, a cache can store reusable pieces of your build environment and use them across multiple builds. Local caching stores a cache on the build host itself. When dependency files are large or builds are frequent, local caching helps to avoid large, repetitive downloads that can slow builds. Means when you are enable caching, those files can be taken from there instead of downloading it again and again, which is basically slowing down the build. Option C, a shared code build project is accessible to the other AWS account and user. The put resource policy API allows an owner to designate the principals with whom the project is shared. A shared code build project does not cache or pre-download any resource. For this reason, it will not improve the build performance. Okay. So it was asking about a shared code build project. And here our requirement was with respect to the performance. Okay. So C is not a valid one. Let's see the G. Create an AWS code artifact repository as an upstream repository and modify the build settings with the repository URI and the authorization token. Code artifact is a fully managed artifact repository service compatible with the package managers. It is mainly used by the companies to address security concerns by storing approved artifact within an AWS account. A code artifact repository would have a negligible effect on the performance when compared to caching. So here our major requirement is suitable with the caching, and that's why we will use option B, where it is asking you in order to do a local caching. Okay. A company storing its application logs in Amazon CloudWatch log. The logs must be encrypted at rest by an AWS key management service customer managed. A developer is working on an application that is in violation of this requirement. What should the developer do to comply with the requirement? Delete the CloudWatch log group, create a new log group by using the AWS CLI, create an asymmetric KMS customer managed key, associate the key with a new log group. Delete the CloudWatch logs log group, create a new log group by using the management console, create a symmetric KMS customer managed key, associate the key with a new log group. Okay. Modify the existing CloudWatch logs log group by using the CLI. Create a symmetric KMS customer managed key, associate the key with the log group. And the last one is modify the existing CloudWatch logs log group by using the management console. Create a symmetric KMS customer managed key, associate the key with the log group. One thing, CloudWatch supports the symmetric KMS customer managed key. So remove all the options with respect to the asymmetric customer managed key. Next option you have to keep in your mind, that is we will use AWS CLI if we have to modify the existing CloudWatch logs. Okay, so let's choose this option, option C. And this is the correct one. Now you can read about it. To use a customer managed key, you must encrypt CloudWatch logs log group by using the CLI. Additionally, the customer managed key must be asymmetric. Okay. You can see why other options are incorrect. CloudWatch log supports only symmetric customer managed key. But a symmetric customer managed key means you're going to use same key for encrypting and decrypting. You can also read about here. Okay. Symmetric versus asymmetric encryption. Okay. You can see. This represents a single 256-bit secret encryption key that never leaves the AWS KMS unencrypted. This represents a mathematically related public key and private key pair that you can use for encryption and decryption or signing and verification, but not both. Okay. The private key never leaves the AWS KMS unencrypted. You can read more about it. What's the difference? What is the difference between symmetric and asymmetric encryption? Symmetric encryption uses the same secret key to perform both the encryption and decryption processes. Okay. And the main point was CloudWatch log supports only the symmetric customer managed key. If you're aware about that, you will be able to remove the incorrect options. Okay. An application consists of an Amazon API gateway, REST API that invokes an AWS Lambda function based on a post method. The Lambda function often fails because of a call to a third-party API inside the function code. There is a requirement to retry failures within a few hours. A developer needs to improve the design to handle exceptions better. The application must have the ability to retry for an amount of time that exceeds the Lambda function's timeout period. Okay. Which solution meets these requirements? Option A, let's read. Create a second Lambda function to handle exceptions. Invoke the original function with the exponential backoff and retry logic. Configure API gateway to invoke the new function instead of the original function. Option B, create an AWS step function state machine. Create a task state that calls the original function with a retry. Set the backoff rate and max attempts values. Configure API gateway to start the state machine instead of to invoke the original Lambda function. Let's read the other options too. Option C is saying create a Lambda external extension. Let's see that. That handles exceptions as necessary. Remove the third-party API calls from the original function. Register the extension with the original function. And fourth one is build a Lambda layer with a library of code that handles exceptions as necessary. Remove the third-party API call from the original function. Configure original Lambda function to call the code in the library. Now, if you're aware about the right use cases of certain pointers, you would be able to eliminate the incorrect answers. When we talk about Lambda layer is basically used in order to layer the dependencies, common dependencies, which you are going to use while executing your Lambda function. Means if you have a Lambda function and that Lambda function is going to use some common dependencies, which will be taken by other Lambda functions too. So instead of increasing the packet size of a Lambda function, you can create a dependencies zip and you can upload that in the Lambda layer so that you can refer it while executing your Lambda function. Okay. So I will remove the option D. Let's see the option B. It is looking somewhat clear to me with respect to the scenario mentioned here. So B is the correct answer. Let's see why B is the correct answer. First of all, let's see why A is not correct. It's possible to synchronously invoke a Lambda function from another Lambda function. However, the new Lambda function must wait until the original function has finished. The new function is still bound by a maximum timeout value. And what was a point? The application must have the ability to retry for an amount of time that exceeds the Lambda function's timeout period. So the new Lambda function which you are going to create, that will again be bounded by the maximum timeout value. Option B, you can use step functions to create a complex workflow. Step function is an orchestration service. including tasks that invoke Lambda functions. Standard workflows can be long-lived and can include tasks with retries that retry a failed task. You can start a state machine from the API gateway REST API by using a post method. Okay. Let's see option C. You can use Lambda extensions to integrate with Lambda with your preferred tools for monitoring, observation, security, and governance. An external extension runs as an independent process in the runtime environment and can continue to run after the function invocation is fully processed. However, the Lambda timeout applies to the entire duration of the function and all its extensions. You can't use extensions to circumvent the maximum timeout value for a Lambda function. Okay, so this is not true. And the code that is called within a Lambda layer is run in the same runtime context as a Lambda function. The call on the code counts towards the same timeout value. So all other options other than B is basically talking about or is basically going to include the same timeout value as of your Lambda function. So those are not relevant options. Okay. So B is a correct choice. Let's move to the next one. A company has an e-commerce application that stores inventory data in Amazon DynamoDB table. Occasionally, during price updates, some items are updated concurrently. The process generates some prices that are different from the prices that the company intended. Which DynamoDB feature should a developer use to enforce consistency in the price update process? Okay. We know when we talk about consistency, consistency is a frequency or a timing, a manner in which most up-to-the-date data will be reflected when you are simultaneously performing a read and write operation. Okay, so here it is saying that sometimes or some items are updated concurrently, occasionally during the price updates. So I will choose an option called conditional writes. Okay, you can read about other options. Option A, atomic counter. An atomic counter is a numeric attribute that updates without interference to other requests. You can use the atomic counter to track page views or other use cases when overcounting or undercounting is tolerable. Okay. Batch operations give you the ability to get or to update multiple items at the same time. However, batch operations do not ensure consistency of the operation. Conditional write. A conditional write succeeds only if the item attributes meets one or more expected conditions. Conditional writes are helpful when you want to ensure that an update exceeds or succeeds only if an item currently has a specific value. Okay, so it can deal with the concurrency. And TTL is basically a value on a table that gives you the ability to specify a per item timestamp. DynamoDB will delete the item shortly after the TTL timestamp is met. Okay, so here my major keyword was enforce consistency, which was getting dealt with the option C. Okay. A mobile app obtains an OpenID token by using a web identity provider login process. The code needs AWS credentials to make a call to the DynamoDB. How can the code obtain AWS credentials? Okay. Read the option. Use an Amazon Cognito identity pool. Call the get OpenID token API, then call the lookup developer identity API. Use an Amazon Cognito user pool, call the get user API, then call the initiate auth API. Use an Amazon Cognito identity pool, call the get API, then call the get credentials for identity API. And finally, you have use an Amazon Cognito user pool, call the get user API, then call the next API. What's that? Let's see it. Verify software token API. Okay. So here, the idea is I am looking for AWS credentials to make a call to the Amazon DynamoDB. Okay. If you're aware about Cognito, Cognito is a service which is used for the user management for web and mobile applications. Okay. Now, Cognito has a concept of a user pool, which acts as an identity store. It has a concept of an identity pool, which is used in order to basically give you the authorization. So in exchange of the token, Cognito identity pool will give you the temporary credentials, which can be used in order to get access to the AWS services. Okay. Use an Amazon Cognito identity pool, call the get ID API, then call the get credentials for identity API. Let's try with this one. It's correct one. So C is the correct answer. Let's see. Let's read about it. The get ID API is called with an open ID token from a web identity provider and returns an Amazon Cognito ID. The get credentials for identity API is called with the Amazon Cognito ID and returns temporary credentials. I told you with exchange of token, it is going to give you the temporary credentials. So option C is a valid option here. Okay. I will keep my discussion till here only as it is a 65 questions practice exam. So I will try to divide this particular practice exam in multiple videos. So don't forget to tell me in the comment section, do you want me to record more such videos with you so that I can discuss the further questions available as a part of this official practice exam. Okay. So I will keep this discussion till here only, but I am eagerly waiting to meet you all in my next discussions where I can discuss more questions as a part of this official practice test exam. So for now, keep learning, keep exploring, and don't forget to add your comments in the comment section so that I can help you out with such more discussions. Thank you very much one more time. Bye-bye and take care, everyone.